Good morning, everybody.
Morning.
Okay, so we are almost at the end of the semester, right? So this is our last lecture before we go for our Thanksgiving break and happy semester break. And after we come back, we will discuss maybe some sorting algorithms, advanced sorting algorithm, and I will discuss test questions and review. So the test will be online. I will decide by this week how the test will be, and during the semester break, I will announce about the test type. Okay, so this week we are discussing graphs, right? In the last lecture, we are discussing graphs. So a graph is a data structure, right? A graph is a data structure, how data are stored or put or implemented. Okay, so a graph is, it consists of some vertices, the black items over here, and some edges, the lines or the connection between two vertices. So here there are 5 vertices, 0, 1, 2, 3, and 4, and these are the edges, 0 to 1, 1 to 0, 0 to 3, 1 to 3, 2 to 3, 2 to 4, 3 to 4, like this. Okay, so last lecture we discussed that a graph can be a directional graph or a unidirectional or both directional. So if there is no direction over here like this is a bidirectional. That means there is a path between a to 1 to 0 and also 0 to 1. Sometimes you may see a graph like this with unique arrow sign, that is unidirectional. Only there is a path from 1 to 4. There is no way, one way road, right? Like one way road. There's no route to go 4 to 1 directly. You may go from 4 to 2, 2 to 1, that is reachable, but there is no direct connection from 4 to 1. This is unidirectional. Okay, and these values, these are called weight of the edge. This may be cost, this may be profit or lost, whatever you say, but in general they are called weight. So this is weight of this edge is 2, weight of this edge is 3, weight of this edge is 4, and weight of this is 6, and so on. So there are many application and algorithms based on graphs. So whenever you take an algorithm course, then you will see that you will learn some algorithms, and there are some popular algorithms and applications solving strategies using graphs. Okay, so for here we will do we will not cover that advanced graph algorithms, but we will cover the basics. Okay, so first one. Okay, so I have another slide from my algorithm analysis course. You hopefully will take that in next year or next semester. Okay, so this, let me cover a few from there. So here are a graph. We know that a graph Z is set of, is combination of, is a, actually it is called relation of B and E. B is the set of vertices and E is the set of nodes. Okay, so unidirectional, that means if there is an edge between U to V, UV, small UV, is an element of this graph, and if there is an edge also U to V and also V to U, then for all U or for all V, okay, belongs to V, and then that is called unidirectional. And directional if there is only one way. Okay, so you know this. One of the things that I want to discuss from here, you see the how a graph A can be represented in computer program. So graph can be represented in two standard ways. One of the way is called adjacency list. List means, okay, adjacency, for instance, linked list. We know about linked list, right? We're familiar with linked list, adjacency linked list. Okay, and adjacency matrix. Matrix is an array and list is a linked list, for instance. So this is, if this is a graph ABCD with nodes ABCD or vertices. So the adjacency list, this is a list A, B, C, D. And if there is a connection from A to B, so we expand it over here from A to B. And if there is a connection from B to B, see this connection from, if there's a connection from A to D, so A to, also there's connection from A to B and also A to D. So this is, so the order over here is doesn't matter. So okay, that's good. So over here it says A, so there is connection from A to B and A to D. So you write A to B and also D. This does not mean B to D. Okay, this means A to B and A to D, and also A to C, and also A to C. Okay, and from B, so there is connection from B to A and B to C. So B to A and B to C. So order doesn't matter, even if you can give D over here and if you give B over here, okay, that is fine. Okay, any order is fine. Okay, from C there are three, right? C to D, C to B and C to A, C to D, C to B and C to A. Whatever you write, you can write D over here, A over here, and B over here. B over here, or D over here, B over here, E over here, no problem. Any order is fine. This order doesn't mean anything, okay? And from D, there are two connections, D to A and D to C. This is called adjacency list, okay? This is called adjacency list, and another is a linked list, kind of linked list is implemented this way. And another one is adjacency matrix. It's a two-dimensional matrix, okay? We may call this matrix G or whatever you name it, okay? This is a 4x4 dimensional. Why do you need a 4x4 dimensional matrix? Why do you need? Because there are 4 vertices. So we say, so there are 4 vertices, for instance, G, so we'll make 4 vertices, 4 rows and 4 columns. So here, this is 1, 1. So there is no loop from 1 to 1. If there is a loop like this, then I would say 1 over here. Okay, but there is no such loop over here, so this is 0. And this, there is a connection from A to B, so this A to, that means this is 1. This rename that 1, or you can say A, B, C, D. You can give this name A, B, C, D, same thing. Either you can give this name or this name. But in array, we put the dimension or indices with number 0, 1, 2, 3, 4, like this way. So you can put 0, 0, 0, 1, 2, or 1, whatever. No. So if there is a connection between A to B from 1 to 2, then we put 1 over here. So there is a path from A to B, so then we put 1 over here. Okay, this 1, 0, and 1, they denote, okay, they denote that whether there is a connection between 2 nodes, nothing else. These do not indicate weight. Okay, these are not weight. Okay, just indicates whether there is a connection or not. Okay, very simple. Okay, and from adjacency list or adjacency matrix, we can do, okay, so we can do a lot of things. For instance, we can find a reachability matrix. A reachability matrix is the matrix that denotes how many ways are there to reach from one node to another node. How many total ways to reach from one node to another node. So if G is given a graph like this, we can write an adjacency matrix like this, right? Just we saw over here a minute ago. We can draw an adjacency Okay, if G is given like this, we can draw an adjacency matrix like this, right? So here that is the adjacency matrix. Okay, let us verify it whether it is an adjacency matrix or not. Okay, so here we know that for this one, so so there is no self loop. So A2 1 to 1 is 0. Okay, there is a path from 1 to 2. This is 1. Okay, and there is a path from, there is no path from 1 to 3. This is 0. And there is a path from 1 to 4. This is 1. And there is a path from 2 to 1. So 1. And there is no self loop from 2 to 2. So 0. There is no path from 2 to 3. So 0. There is no path from 2 to 4. 0. There is a path from 3 to 1. 3 to 1, so on. There is a path from 3 to 2, so on. There is no self loop 3 to 3, so 0. There is a path from 3 to 4, this is 1. Okay, there is no path from 4 to 1, so 0. There is a path from 4 to 2, so 1. There is no path from 4 to 3, so this is 0. There is no self loop, there is no path, direct path from 4 to 4, so this is 0. So this is A1. A, we put A dash. We can put A dash or A1. A1 is the adjacency list reachability matrix with one single jump. Okay. And so there is a formula. There is an algorithm. So that we saw that. So then it says, in order to find A2 means if there are two edges to reach from one node to another node. A2 means, so A2 can be calculated by A1 is matrix multiplied by A1. So whenever we know that whenever a matrix is multiplied A1 by A, if A is M by N matrix, okay, and A2, A1 is again M by N matrix, okay. So here M equal to N, M equal to N. So that means you can say M by M, okay, and M by M. So that means this M will be crossed out, and then final matrix A2 will be M by M also. This is a square matrix, so easy to multiply. Otherwise, the general rule is that if A equal to M by N matrix and B is only equal to N by, say, N by P matrix, and this, since N equal to N, then it is multipliable. Then A and B will be M by P matrix. Otherwise, if they do not equal, it is not multipliable. Okay. So for the square matrix, since all reachable all what is that called? All adjacency matrix will be a square matrix. All adjacency matrix will be a square matrix. So we don't need to be worried about this situation. It is always multipliable. So multipliable since is multipliable, so A2 can be found by A1 multiplied by A1. Okay, so this is 1 1 0 0 0 1 0 0. This is the A matrix, and if we multiply by 8 again, so then we know then A2. Do you know how many of you know matrix multiplication? How many of you know matrix multiplication?
I don't.
You know? I do not know.
No, I don't know.
Okay, maybe you do not take you did not learn it in high school.
I graduated high school in 2007, so I probably forgot if we did.
Okay, it's a long time ago. So let me recap it, okay? So if let me do it in a fresh screen, okay? So if A matrix equal to A11, A12, A13, okay, and then B11, B22, B23. These will be values A1, A2. These will be 1, 2, 3, 4, negative 1, 2, 3, 4. These will be values, numeric, integer number, okay? And C11, C12, C13. Okay, and B multiply, when I multiply, this is called scalar multiplication. So B11, B12, B13, B21, B22, B23, B31, B32, B33. Okay, this can be any value. This this can be any value 0, 1, 2. So I'm writing in general formula. Okay, the general formula, you can remember that whenever multiplying, whenever we get matrix multiplication, okay, so these row values are multiplied by column values. You can write an arrow like this. Okay, row values are multiplied by column values to get a single cell value. You can write row values, row say corresponding. You can write corresponding. You can write in corresponding row values are multiplied by corresponding column values to get a single cell values. You can write in corresponding row values are multiplied by the corresponding column values to get a cell value. This is the formula, you can remember that, okay? So this one, that means A B11 times this one will be multiplied with this one, B11 plus A12 times B21 plus A13 times B31. So by doing, you will get only one value. For since the wrong number, I'm giving comma over here. Okay, so then by doing, you will get only one value over here. And the second one, you will go this one by this one. Okay, then A11 times B12 plus A12 times B22 plus A13. This is 13, this will be this one into B32. This will be on another value. And the third one, you will multiply this by this one. So then A11 into B13 plus A12 into B23 plus A13 into B33. So then by doing so, you will get here the unique value, and you will get unique value, another unique value, and you will get another unique value. Maybe that value is C. So let us say that this multiplication matrix will be a C matrix. Okay, so maybe this is C. For instance, this is C, this is C, then this will be C11. Okay. Similarly, then again, this row will be multiplied by this column. So then the next one, B11 into, sorry, A11. I did a mistake over here. I did a mistake. Sorry, let me fix it. Okay, this what should better should if we should give all A. Okay, it should be better if we, I can give any name, but its corresponding should be fine. So if I say A21, A22, A23, A31, A32, A33, then this is fine. Okay, all A and all A, this is good. So here, then this will be, are you following me?
Yep.
Okay, so now tell me what will be the next one. Quickly, let us do it quickly. A21 times B11 plus A22 times B21. Each of these values, the corresponding values will be B21 plus A23 into B31. So I'm getting another value. Maybe C21. There's value maybe that we can name this C21. Okay. It doesn't matter. I'm telling you that how I'm getting one values, single values. Maybe C12, maybe this one C13. This is not division sign, okay? That I'm giving name of this one, okay? So actually, how many multiplication we need? So this matrix is 3 by 3 matrix, right? And this matrix is 3 by 3 matrix. So you need total multiplication 3 times 3 times 3. Need total. Need a total of 3 by 3 by 3 equal to 27 multiplications. Like this is one multiplication, this is two multiplication, three. Oh no, this is one multiplication, this is another multiplication, this is another multiplication. So like this way there will be 23 multiplications. Sorry, 27 multiplication. Okay, so I'm sure I have shown only 3 multiplication over here, 1 2 3, another 1 2 3, 1 2 3, like this way. So now can you fill it out? This is the formula. Okay, and then for the next one, this will be, this row will be multiplied by this column again. So for this one, A21 into B12 plus A22 into B22 plus A23 into B32, and the next one, this value will be A21 times, this one will be go like this. Okay, so A21 times B13 plus A22 times B23 plus A23 into B33. Okay, and then there will be another value over here. So let me write this one. This one will be multiplied by this one first. Then A31 into B11 plus A32 into B21 plus A33 into B31. Okay, then this value will be, then again this one will be multiplied by this. So A31 into B12 plus, okay, tell me the next one please. A32 into B22 plus A33 into B32 plus this one, right? And then last one will be like this way. Okay, A31 into B13 plus A32 into B23 plus A33 into B33. If you look at, so this is the, you get another unique value over here, you will get another unique value here, you will get another unique value here, and you will get another unique value here, and you will get another unique value here. And by this way, you will get a single value. Maybe that, like this value will be C31, this one will be C32, this will be C33. I'm giving name, this one whatever name. Maybe this one will be C22, C23. So this, how this will be, how will this will, a matrix is multiplied. So now do you understand how a matrix is multiplied with another matrix? Okay. So like this is my A matrix. Okay, reachability matrix A. Then if we multiply A by another A, then you will get A2. If you multiply A2 by another A1, then you will get A3. Okay, and if you multiply A3 by another A1 by again A1, then you will get A4. Okay, this is how it is generated. And actually the final reachability matrix is R. That means R equal to A dash or A2 or A3 or A4. That means if there is, it is reachable either through 1 or 2 or 3 or 4 ages. Okay, then it is fine. Okay, so here I think okay, there is a mistake over here. So if you do a Google search, you can get a complete program how to multiply matrices, two matrices. Like for instance, if you just do a Google search, I did a Google search, and you can find your program in all languages. So here in my replit, I added this program. It's very simple. It is from online, and it is well known to everybody. Okay, so since it is a matrix, is a two-dimensional matrix, row by column, so we need a two for loop. One is for row, another for column. Okay, and then this is the formula. For instance, if let us double check. So this is if A matrix is 0 1 0 1 0 1 0 1, then 1 0 0 0 1 0 0 0, and then 1 1 0 1 1 1 0 1, and then 0 1 0 0 0 1 0 0, and the same matrix is over here. You can say another one. Matrix 2 is same. Okay, and then if we multiply this, the multiplication result is over here. The codes are available here, and then if we run it, then this is the A2 matrix. The A2 matrix should be like this: 1 1 0 0 1 1 0 0 1 1 0 1 1 1 0 1 1 2 0 1 and 1 0. Either there is I did not double check either the code or this one. You can double check. There is a mistake either in my code, either in this code. It's not my code. It's either in this code or in this slide. There is a mistake. So I see that it shows 1 2. It shows 2 over here, right? So it shows 2 over here. Maybe 2 will be over here. Okay. So you can get this program. It is available in my Replit account. You can get this program, and then you can write a program to find the reachability matrix. And the assignment, there is an assignment to find the reachability matrix. Okay. Does anyone has any question for this?
No.
I'm giving you this my program URL. You can use this program. Okay. So there's an algorithm. It is called Warshall algorithm to compute reachability matrix. Okay. Oh, okay. Maybe I understand. Maybe the program, the slide is correct. So actually the Warshall algorithm, it says the Boolean matrix. It will say either 0 or 1, either 0 or 1. So let me see. The program is over here for matrix multiplication. The program is here for matrix multiplication, not for Warshall algorithm. So in order to find reachability matrix, you need to change this program a little bit. Okay, you can do a Google search to find that, or you can use this program and change it to yourself. Okay, this is why it says, let me see. So either this did not come with 2. Okay, this is 1. Okay, if this is not, it's not 0, then 1. So then for war, if there is a connection either from this is why from 1, it will come either 0 or 1 1 1 1 for reachability matrix. Okay, hold on a second. Let me show. Hold on, so let me see that. Okay. Okay, so the program is over here. Whatever you see that you can say, okay, two things. So using this program, actually we can find a Boolean reachability matrix. If we say Boolean reachability matrix, then it will be 1 1 1 1. It cannot be more than one. But if you are asked to find an integral reachability matrix, remember the difference. If you are asked to find an integral reachability matrix, then the sign will be plus over here. Okay, instead of or over here, then the sign will be plus. And in that case, the program you can use matrix multiplication. That value will be can be more than one. So the difference between, remember that one is called Boolean reachability matrix and another is integral reachability matrix. Boolean reachability matrix, it will give you only Boolean value 0 or 1. And for integral reachability matrix, you will give more than one. So in our assignments, let us see the assignment. What does the assignment say? Okay, you said the assignment is asking for integer reachability matrix. Okay, that means that's good. You can use that matrix multiplication, direct matrix multiplication formula. You can use my program. Good. To start. Okay, remember that in the integer means integer reachability matrix. So that if a matrix, for instance, is like given like this 0 1 1 1, okay, then reachability matrix will be like this 1 2 2 2. Let us check this code. Okay, let us check this code with this program code. Okay, and sample runs. Okay. On the sample run. This one. Okay, 3 by 3. It is will be easy to stand. We need to make some changes over here. R1, R2. This will be 3 by 3 matrix. 3 by 3, and then 3 by 3. So over here, I need to change. Okay, over here 0 1 1. Right, 0 1 1, and then 1 0 0 1 0 0, and then 1 0 1 0 0 1 0. Then I don't need the last. Okay, this one, and then same one, it will be over here. Okay, 0 1 1 1 0 0 0 1 0. Okay, and then if I multiply this will give me this matrix. So this is A2. Okay, this is A2, and then in order to find reachability matrix, you need to find A2, A3 also. So how can I find A3? A3 will be multiplication of this by, okay, by A1 again, matrix 1 again. So you need to expand this program. Okay, so you got multiplication 1 matrix, and then you need to use that matrix with another matrix with this one. Okay, you need to declare another matrix A3, and by this way, so this is A2, and then you will get A3 later. Okay, for instance, I can show you this is my, if this is my, this one is my what is called A2, and then for instance, for now say 1 1 0 and 0 1 1 and then 1 0 0. Okay, this is my A2. Then and this is A1, then I will get A3. A3 is getting this one. Okay, this is A3. Okay, I can say this is in matrix 3. What is this value? 1 1 1 1 2 1 0 1 1. Okay, now integer reachability matrix is then the so integer reachability matrix will be like this. We need to add this matrix with all other previous matrices. All three matrices add, right? So these 3 will be added. Okay, so then 1 plus 0 plus 1 is 2. 1 plus 1 plus 1 is 3. Okay, and then 0 plus 1 plus 1 is 2. We need to add corresponding cells. Then 1 plus 1 plus 1 is 3. And then 1 plus this 1 plus 2, 3. I'm sorry. 3. And then it will be like this. Okay. Sorry, it is traveling. Does anyone has any question about this integer reachability matrix? So now we can start the assignment 9. Okay, you can follow my program, and then so they need to expand this program. You need to get more values. Okay. Okay, so let us finish this one quickly. Okay, and this one will be 1 plus 0 plus 0. This will be 1. Okay, and then this value will be 1 plus 0 plus 0, 1. And this value will be 1 0 plus 1 plus 1, 2. And this value will be 0 plus 0 plus 1, 1. So this is the integer reachability matrix. Okay, 2 3 2 2 3 2 2. Okay, there's a mistake over here. Maybe 1 1 1. See 3. Somehow there's a mistake. Maybe this is 0. Let me rerun this program. I will see. There's a mistake. So this one is A2, right? A2 as 1 1. This is A2. 1 1 1 1 2. Okay, this will be 1 1 2 1. Okay. So where is my mistake? 1 2 1 1 1 1 1 2 1 0 1 2, then 1 2 1 2 2 1 2 2 1. This will be 2 is 1 1. Somehow either my program code or this one is missing. You can double check. Okay, so this is how you will start the assignments. Okay, to find integer reachability matrix. Okay, but the algorithm over here, the slide, that is called Boolean reachability matrix. Okay, so Boolean reachability matrix is different than the Boolean reachability matrix. Will have only one if there is one either in these three. Either this value is in one, either way, either here or here or here, then it will be one. Okay, does anyone has any other question? Okay, now you can start the assignment 9. Okay, and then we discussed in our last lecture graph traversal. How do we traverse a graph? In two ways. It's called breadth first search and in the depth first search. Okay, so in the depth, in the breadth first search, that is easy to go. Visit nodes level by level. Okay, so for instance, if you have a graph like this, this, okay, this, maybe this. Then go level by level. This is the first level 1, level 2, level 3. Okay, so if you have a name A, B, D, C, E, F, G. So then breadth first search will be BFS will be A. Then you can go either B or D. Either B or D. This can change. And then E, C, F, G. And E, C, F, G. You can go, you can interchange this in any order. Okay, so there will be multiple breadth first search sequences. So that means, for instance, this can be A, B, D, E, C, F, G, or say G, F, or A, B, D, E. Okay, and then instead of C, you can see letter, you can say G, F, C, like many combination. But one of the things that you start one level, you finish. Okay, and then you start another level, you complete, and you go another level, you complete. All these will be together. Okay, and depth first search, DFS, will start one level and go with the wherever it starts from, it will go all the way end. Okay, so here whenever it starts from A, So then you say A, it will start from A, then down, going down depth B, and then going down, then E, and then it is down C, it may be down F, and then it is going to G. Okay, then when it finishes all these, then it will come back and whatever is missing, then D is missing. And there will be multiple combination for this. Okay. Does anyone has any question about this? Breadth first search and depth first search?
No, sir.
In our last lecture, I discussed some of this, and I discussed from my slide from algorithm analysis slides. This one. So here, breadth first. You start from a point. If you are asked to breadth first or depth first, you will be given a point, starting point. For instance, starting from X. Then from X, this is one level. Okay, and then X, okay, M and P, and these are on one level. So like I could write, like I could draw this one differently, slightly differently. Like I could say, if I draw an actual graph type, I could say X, and then M, and then P, and then Y, and then Y has 3, N, Q, and G. Okay, maybe this is more visible, more better than this, right? So now starting from X, so then X, and then these are on another level, right? And the X, and then X, then M, Y, P, X, M, Y, P, or M, P, Y, or X, M, Y, P, whatever you want, 3 orders you can go. And then when you finish this row level, then you will go this level. Okay, so when you start first level, and first level, level 1, level 2, level 3. Okay, this is why. So this is why this is right side is incorrect. So I said that X, Y, G. So X, Y, G. You cannot go to G until you finish for breadth first, until you cover M and P. This is why it's a mistake. And then even for this one, if you go X, Y, P, Q, X, Y, P, then you cannot go to Q. You need to go to M. Okay. So if you redraw this graph maybe differently, you can easily understand. So there will be some quiz questions. Okay, like you will be given some graph like this, and you will be asked to check which one of the breadth first or depth first is incorrect or correct. Does anyone has any question about this? So breadth first and then depth first. Okay, this one is depth first. Okay, so this one, you said this one is breadth first. First one is just breadth first search, and second, same thing. If we do depth first search, then we can rewrite this one. For instance, X, and then it has any order you can say. You can P, it has M, and any order you can say Y, and then Y has 3. Y has one side, three children. G, Y has N, Y has Q. You can give in any order. That doesn't matter. Okay, now for the depth first search, you will start from 1. You will start from X, then Y, and then Q, either X, Y, or N, X, Y, or G, whatever you say. Okay, all of these are valid. Okay, whenever you finish all of this, then you will cover all other twos, and then you will cover M, and then last P, or P or M. So you see that these will be all the way last. But these are incorrect. Why these are incorrect? So X, M, P. I cannot go. The problem is over here. I cannot go this way. And even this one, if you go X, Y, G, X, Y, Z is correct, then you need to cover N and Q first. So N is, you cannot come back to M until you cover all of this. So this is the depth first search. So it goes to the deepest, is the spelling correct? Level first. Okay, it goes by level. First level first, second level second, third level third, this way. Does anyone has any question about this? Okay, let us see. We have a few more minutes. Let us see what else we have left. Okay, the algorithms are given over here. We are not writing algorithm over here. Okay, so I'm not going to in depth about algorithm because our assignment is only about reachability matrix. So let us focus on reachability matrix, and there are some algorithms. Okay, so we are not covering those algorithms like Dijkstra algorithm, Bellman-Ford algorithm, and other algorithms. Those actually algorithms we actually cover this in our in our data in our algorithm analysis course. Okay, there are some algorithms, popular algorithms like called Prim's algorithm, Kruskal algorithm, okay, and then Dijkstra algorithm. Dijkstra algorithm and Bellman-Ford algorithms. We covered this algorithm in our data structure course, so we don't need this over here. But if you are interested in, I can upload this slide in your D12 cell if you need to cover this, but you don't need. You don't need it. Okay, we have a few more minutes. We will take our attendance, but before we wrap up, does anyone has any question? So now we can start the assignment. Okay, the assignment 9 is about graph. It is about integer reachability matrix. So you can follow my program. Okay, and then You can expand your program and then you can get it. Okay. Does anyone has any question before we get our attendance? How many of you are there?
No.
Okay, so let us get our attendance. So thank you so much. Actually, we are almost at the end of the semester. We have one more last week. We will cover something, only one more lecture after the break. And in this course that you get startup, you learn some data structures, and actually half of the course you review at 1322 CS2 element. Okay, and the some elements, some concept that, for instance, graph, you will learn this in even learn this more whenever you take algorithm analysis course. Okay, almost all of this will be covered again, reviewed in algorithm analysis course. Okay. So, but one thing is that in this semester you have learned a new language, C++ by yourself, because of course it is not our goal to teach you C++ language. Okay, I learned C++ myself. It's a long time ago, about 25 years ago. So once you learn one language, it is easy for you to understand another language. Okay, that don't worry. So let us give that attendance. Let's take that attendance. Okay, everybody, please respond to attendance. It is November 18th, right? 18th November. Okay, and Jason.
Here.
Matthew. Daniel. Myers.
Here.
Antonio.
Here.
Jasmine. Chaton. Alicia. Tyler.
Here.
Ernest. Angel. Someone please check in the chat window. If someone gives attendance in the chat, please let me know. Thank you. Angel. Jaden. Cody. Isaiah.
Here.
Isaiah.
Here.
Jimmy.
Here.
Savvy. Loyal.
Here.
Dave.
Here.
Karen. Mikhail.
Here.
Jax. Jess Morning. James. Brandon. Noah.
Brandon is here.
Brandon is here. Noah. Alan. Kenya.
Here.
Jimmy.
Here.
Hey, Professor.
Lilivia.
Ernest is here, Professor.
Ernest is here. Where is Ernest?
Number 11.
I'm here too.
What is your
number
name?
9.
Number 9. Alicia?
Yeah.
Okay, thank you.
And number 13.
13. Who is this?
Jaden. Thank you.
Jesus. Oh, Lilivia. Lilivia is here. Jesus. Cameron. Sebastian.
Here.
Alice.
Here.
Justin. Daniel. Andrew.
Here.
Nicholas.
Here.
Jessica. Okay, I have, let me give me 1 more minute, please. Let us. Okay, let me see the quizzes. Assignments are up, and then quizzes, we have quiz 5. Okay, we have gone quiz 5, and I will post 1 more quiz. That will be quiz 6. Okay, that will be due after the Thanksgiving break. Okay, after the semester break, that will be due. Okay, and quiz 6 will be optional. You can drop it, and if you take it, then your lowest quiz grade will be replaced. Lowest quiz grade will be dropped. Okay, that means if you take more than 5 quizzes, then your best 5 quiz grades will be considered. Okay, and there is no rush. That will be due in the last week, in the review week. Okay, I'll upload that. Does anyone has any question or concern about that?
I have a question, Earl.
Yes.
Is it possible to get the upcoming assignment extended to Sunday?
This assignment?
Yeah, the for hashing.
Okay, it's easy. I can do it. Hashing. So when do you like it?
Sunday would work for me.
Or after break would also be great.
Oh yeah, after break, I'm down for
After
that.
break, that will be too late. So let me see. It is 19th, right? Because there is one more assignments. What I can do, I can give you to middle of the next week or maybe 1 week, but there will be semester break. Is it okay that I can give it Thanksgiving?
That works for me.
Yeah, that's great. Thank you.
Don't become mad that I'm giving you some work in that break, right? But I'm giving an extended time. Okay.
Very much appreciated. Thank you.
26.
And regarding the final exam, is there a study guide already posted?
No. I will post during this break. Hopefully this weekend. Okay.
Okay.
I will post. So I'm giving 1 more week. Okay. So you asked for maybe for the weekend. Okay. And I'm giving. Okay. One more thing. Let me make it Monday, and then after that I will make it 2 more days. Okay, let me make it 23 first. Okay, and then there will be extended deadline. I will make that on that time 26. Okay, extended deadline will be 26, but I'm make it 23 for now. Okay,
Copy. Thank you.
So I'm giving you 23 for this one because there will be another extended deadline. So this one, right? Hash tables, right? Better do it before do it if you go to break. Okay, if you enjoy your break, then restful break, then complete it before you go. Does anyone has any question?
You mentioned at the beginning of the lecture about test 3. Is that like test 3 or test 3 of final?
That will be final. Test 3
and you said it was online?
It will be online, so you're taking this on. I will say, okay, if there is a hard restriction that it needs to be in campus, then I cannot, whatever, I will discuss with the professor. I went to the department last time. I could not see him. I didn't find him. Hopefully I will find him today and then I will discuss. And I will post it today, okay?
Well, online is fine though, but
I will make an announcement. So online is fine, I know, but if the department has a restriction, program has a restriction to be face to face for the final. Maybe a professor told me, the coordinator of the course, he told me that it might be restricted. So if there is a restriction, I cannot do it, okay? But from my side, I will give you best option.
The test scores are not showing up in grades.
Oh, okay. I will post that. I will check that. Okay. I will check that. Nobody told me. Thank you so much. You have a good day.
Thank you.
And have a good weekend and good semester break. Thank you. Bye bye.